1. The Earth. The story of origin and evolution of the Earth. A large number of hypotheses were put forth by different philosophers and scientists regarding the origin of the Earth. One of the earlier and popular arguments was by German philosopher Immanuel Kant. Mathematician Laplace revised it in 1796. It is known as nebular hypothesis. The hypothesis considered that the planets were formed out of a cloud of material associated with a youthful sun, which was slowly rotating. Modern theories on origin of the universe. The most popular argument regarding the origin of the universe is the Big Bang theory. It is also called expanding universe hypothesis. Edwin Hubble, in 1920, provided evidence that the universe is expanding. As time passes, galaxies move further and further apart. For example, take a balloon and mark some points on it to represent the galaxies. Now, if you start inflating the balloon, the points marked on the balloon will appear to be moving away from each other as the balloon expands, and points themselves will also expand. Similarly, the distance between the galaxies is also found to be increasing, and thereby, the universe is considered to be expanding. Big Bang theory. In the beginning, all matter forming the universe existed in one place in the form of a tiny ball, singular atom, with an unimaginably small volume, infinite temperature and infinite density. At the Big Bang, the tiny ball exploded violently. This led to a huge expansion. It is now generally accepted that the event of Big Bang took place 13.7 billion years before the present. The expansion continues even to the present day. As it grew, some energy was converted into matter. There was particularly rapid expansion within fractions of a second after the bang. Thereafter, the expansion has slowed down. Within first 3 minutes from the Big Bang event, the first atom began to form. Within 300,000 years from the Big Bang, temperature dropped to 4,500 Kelvin and gave rise to atomic matter. The universe became transparent. The expansion of universe means increase in space between the galaxies. The star formation. The distribution of matter and energy was not even in the early universe. These initial density differences gave rise to differences in gravitational forces, and it caused the matter to get drawn together. These form the basis for development of galaxies. A galaxy contains a large number of stars. Galaxies spread over vast distances that are measured in thousands of light years. The diameters of individual galaxies range from 80,000 to 150,000 light years. A galaxy starts to form by accumulation of hydrogen gas in the form of a very large cloud called nebula. Eventually, growing nebula develops localized clumps of gas. These clumps continue to grow into even denser gaseous bodies, giving rise to formation of stars. The formation of stars is believed to have taken place some 5 to 6 billion years ago. Formation of planets. The following are considered to be the stages in the development of planets. The stars are localized lumps of gas within a nebula. The gravitational force within the lumps leads to the formation of a core to the gas cloud, and a huge rotating disk of gas and dust develops around the gas core. In the next stage, the gas cloud starts getting condensed, and the matter around the core develops into small rounded objects. These small rounded objects, by the process of cohesion, develop into what is called planetesimals. Larger bodies start forming by collision, and gravitational attraction causes the material to stick together. Planetesimals are a large number of smaller bodies. In the final stage, these large number of small planetesimals accrete to form a fewer large bodies in the form of planets. Our solar system. Our solar system consists of 8 planets. The nebula from which our solar system is supposed to have been formed started its collapse and core formation sometime 5 to 5.6 billion years ago, and the planets were formed about 4.6 billion years ago. Our solar system consists of the Sun, the star, 8 planets, 63 moons, millions of smaller bodies like asteroids and comets, and huge quantity of dust grains and gases. Out of the 8 planets, Mercury, Venus, Earth and Mars are called as the inner planets, as they lie between the Sun and the belt of asteroids. The other 4 planets are called the outer planets. Alternatively, the first 4 are called terrestrial, meaning Earth-like, as they are made up of rock and metals, and have relatively high densities. The rest 4 are called Jovian or gas giant planets. Jovian means Jupiter-like. Most of them are much larger than the terrestrial planets and have thick atmosphere, mostly of helium and hydrogen. All the planets were formed in the same period, sometime about 4.6 billion years ago. Till recently, August 2006, Pluto was also considered a planet. However, in a meeting of the International Astronomical Union, a decision was taken that Pluto, like other celestial objects, 2003 UB313 discovered in recent past, may be called dwarf planet. Some data regarding our solar system are given in the box below. The difference between terrestrial and Jovian planets can be attributed to the following conditions. The terrestrial planets were formed in the close vicinity of the parent star, where it was too warm for gases to condense to solid particles. Jovian planets were formed at quite a distant location. The solar wind was most intense nearer the Sun, so it blew off lots of gas and dust from the terrestrial planets. The solar winds were not all that intense to cause similar removal of gases from the Jovian planets. The terrestrial planets are smaller and their lower gravity could not hold the escaping gases. The Moon. The Moon is the only natural satellite of the Earth. Like the origin of the Earth, there have been attempts to explain how the Moon was formed. In 1838, Sir George Darwin suggested that initially, the Earth and the Moon formed a single rapidly rotating body. The whole mass became a dumbbell-shaped body and eventually it broke. It was also suggested that the material forming the Moon was separated from what we have at present, the depression occupied by the Pacific Ocean. However, the present scientists do not accept either of the explanations. It is now generally believed that the formation of Moon, as a satellite of the Earth, is an outcome of giant impact, or what is described as the Big Splat. A body of the size of 1 to 3 times that of Mars collided into the Earth sometime shortly after the Earth was formed. It blasted a large part of the Earth into space. This portion of blasted material then continued to orbit the Earth and eventually formed into the present Moon about 4.44 billion years ago. Evolution of the Earth. Do you know that the planet Earth initially was a barren, rocky and hot object with a thin atmosphere of hydrogen and helium? This is far from the present-day picture of the Earth. Hence, there must have been some events processes which may have caused this change from rocky, barren and hot Earth to a beautiful planet with ample amount of water and conducive atmosphere favoring the existence of life. The period between 4,600 million years and the present led to the evolution of life on Earth's surface. The Earth has a layered structure. From the outermost end of the atmosphere to the center of the Earth, the material that exists is not uniform. The atmospheric matter has the least density. From the surface to deeper depths, the Earth's interior has different zones, and each of these contains materials with different characteristics. Evolution of lithosphere. The Earth was mostly in a volatile state during its primordial stage. Due to gradual increase in density, the temperature inside has increased. As a result, the material inside started getting separated depending on their densities. This allowed heavier materials, like iron, to sink towards the center of the Earth and the lighter ones to move towards the surface. With passage of time, it cooled further and solidified and condensed into a smaller size. This later led to the development of the outer surface in the form of a crust. During the formation of the Moon, due to the giant impact, the Earth was further heated up. It is through the process of differentiation that the Earth-forming material got separated into different layers. Starting from the surface to the central parts, we have layers like the crust, mantle, outer core and inner core. From the crust to the core, the density of the material increases. Evolution of atmosphere and hydrosphere. The present composition of Earth's atmosphere is chiefly contributed by nitrogen and oxygen. There are three stages in the evolution of the present atmosphere. The first stage is marked by the loss of primordial atmosphere. In the second stage, the hot interior of the Earth contributed to the evolution of the atmosphere. Finally, the composition of the atmosphere was modified by the living world through the process of photosynthesis. The early atmosphere, with hydrogen and helium, is supposed to have been stripped off as a result of the solar winds. This happened not only in case of the Earth, but also in all the terrestrial planets, which were supposed to have lost their primordial atmosphere through the impact of solar winds. During the cooling of the Earth, gases and water vapor were released from the interior solid Earth. This started the evolution of the present atmosphere. The early atmosphere largely contained water vapor, nitrogen, carbon dioxide, methane, ammonia and very little of free oxygen. The process through which the gases were outpoured from the interior is called degassing. The carbon dioxide in the atmosphere got dissolved in rainwater and the temperature further decreased, causing more condensation and more rains. The rainwater falling onto the surface got collected in the depressions to give rise to oceans. The Earth's oceans were formed within 500 million years from the formation of the Earth. This tells us that the oceans are as old as 4,000 million years. Sometime around 3,800 million years ago, life began to evolve. However, around 2,500 to 3,000 million years before the present, the process of photosynthesis got evolved. Life was confined to the oceans for a long time. Oceans began to have the contribution of oxygen through the process of photosynthesis. Eventually, oceans were saturated with oxygen, and 2,000 million years ago, oxygen began to flood the atmosphere. Origin of life. The last phase in the evolution of the Earth relates to the origin and evolution of life. It is undoubtedly clear that initially the Earth or even the atmosphere of the Earth was not conducive for the development of life. Modern scientists refer to the origin of life as a kind of chemical reaction, which first generated complex organic molecules and assembled them. This assemblage was such that they could duplicate themselves, converting inanimate matter into living substance. The record of life that existed on this planet in different periods is found in rocks in the form of fossils. The microscopic structures closely related to the present form of blue algae have been found in geological formations much older than some 3,000 million years. It can be assumed that life began to evolve sometime 3,800 million years ago. The summary of evolution of life from unicellular bacteria to the modern man is given in the geological time scale on page 18.